All right, here we're looking at our section A1. So this is part of our algebra review. So our learning targets for today, we have quite a few, and these will go fairly quickly. We're going to work with sets and some set notation. Secondly, we're going to graph inequalities. We're going to find the distance on the real number line. We're going to evaluate some algebraic expressions and determine the domain. Then we're going to look at some laws of exponents, and along with those some square roots, and then we're going to use our calculator to evaluate exponents. Okay, so the first thing we want to look at is that set notation. Okay, so here's kind of our set notation. We always use brackets to include our sets. So we want to read this as D, or so here in our book it works through D, but here we're going to say E is the set of all x such that x is an even digit. Okay, so I'm looking at my set E is the set that x is an even digit. So now I can include those in my brackets. So then this O, this set odd, is all x's such that x is an odd digit. So those are included in that bracket. Okay, so we always want to use brackets to include our sets, and we look inside the brackets here to determine what we're actually looking for. Okay, so now we're going to look at some definitions. So if A and B are sets, the intersection, which is denoted by this kind of upside down U, that's the intersection, is the pieces, the parts of that set that are in both A and B. So an intersection, right, I can think of this as like a road. So an intersection of a road is where both parts go. So same here with these sets. This intersection is included in both of them. So the union of A with B, where this is this normal way U, is that belong to either A or B. So it's all the pieces that are included in either one. So we're going to look at an example of that. So first, we're going to find the intersection and units of these sets. Okay, so here's A. Set A is 1, 3, 5, 8. Set B is 3, 5, 7. And set C is 2, 4, 6, 8. First, again, let's look at this upside down U. The upside down U tells me it's the intersection. So I want to find the intersection of A and B. And remember, intersection is the pieces that are the same. Let me see if I have the solution on this next page. I do. So here we have the solution, right? So I look at my sets. So here's set A and set B, and I try and find the pieces that are the same in both, and I see that 3 and 5 are the same in both. So now let's look at part B. So A, this is a union, and the way I remember the difference between union and intersection is union is a U, so it's actually a U. So the union of A and B. So I want to include everything that's in both of them. Okay, so again, I write out my sets. So I have 1, 3, 5, 7, 8. I don't want to include these values twice, 3 and 5, because I know that it's the same value and it's included in both of them. So let's look at part C. So here we have some parentheses, and we always want to do the parentheses first. So first I want to find the union of A and C, and then the intersection of that and B. So again, I can write out all of my sets and what I have. So first, again, right, I find the union of A and C, which is any number that's included in either of them. So 1, 2, 3, 4, 5, 6, 8. Now I'm finding the intersection of B and that union. So anything that's the same. So I see I have a 3 and a 5 in both of them. So that's going to be the final answer for that one. So our next definition. So if A is a set, the complement of A is everything that's not in A, right? So complement means it's not included in A. So there are several different ways that you can write that. We can write it as either A with a line over it, or A apostrophe is written in some books. So that just means the complement of A. Okay, so finding the complement of a set. So I have my universal set. So here's my universal set. So 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all of my single digits. So if A is 1, 3, 5, 7, 9, so then the complement of A, so the stuff that's not included in A, would be 2, 4, 6, 8. So I'm using all of the digits, all of the numbers in my universal set, and whatever's not in A will go in the complement of A. So here's just some figures that walk us through this. So I see I have a universal set, and my universal set is all digits or all values that we're looking at. I can also have a subset. Okay, so that's kind of my sideways U with a line underneath it. So here I see I have a set B, and I have a subset. So A is the subset B. So how I like to think about this one is the universal set is all students at PGA. So then I have a subset. My subset would be, for example, seniors, right? Because seniors are included in that universal set. And then my subset might be seniors that love ice cream, right? Because maybe not everybody loves ice cream, but a group of them do. So that is included in my set B, which is included in my universal set. That's what this is kind of telling me. And this is the notation of a subset. Okay? I can also have disjoint sets. Okay? And that's where this like 0 with a line comes through. That tells me that they don't have anything to do with each other. They don't overlap at all in my universal set. So some more figures, okay? So we've looked at an intersection, right? And this is just a way to visualize it. The intersection is the pieces that are in both of them. So then I have a union. A union is all the pieces of all of them. Then again, my complement. If A is my set, right, then my complement is everything that's not included in my set. So these are just a couple of ways that we can visualize those sets. Okay, so now we're going to be looking at some properties, and hopefully you remember these. So the distributive property, right, is where if I have something outside of my parentheses and I'm multiplying, I multiply that thing, so in this case A, times everything inside my parentheses. Then I also have my zero product property. This comes into play a lot when we're factoring. So if A times B equals 0, then either A equals 0 or B equals 0, or they both equal 0. And when I'm factoring, I can break this down into this chunk equals 0 and this chunk equals 0, and then solve for both of them. Okay, so now let's look at our real number line. And we're not going to spend a lot of time on this because you've seen a number line a lot. So we're going to be dealing with the number line quite a bit, and it's a really easy way to visualize things, right? And we just know, especially talking absolute value, that we're talking about how many jumps away from 0 am I. That's what this is really looking at. Okay. So we're going to find some coordinates, and that coordinate is just the place that I'm looking at on my real number line. Okay. So again, here's my number line. Here's 0. So I've got my negative real numbers and my positive real numbers. We will get into imaginary numbers this year, but for now, let's live in some real numbers. Okay. So now we're going to be graphing some inequalities. This is our one of our learning targets. Okay. So if I say that A is less than B, I know that it's going to be more to the left of B on my number line. If A equals B, that means they're on the same place on my number line. And then if B, there we go. If A is greater than B, I know that A is going to be to the right. So that's just a kind of simple way to look at it. So we're going to graph some. So this is just slightly different than what you've seen before. So I'm going to graph x is greater than 4, and then x is less than or equal to 5. And here we can use a little bit different notation. Okay, so here we can use parentheses and brackets as well. So you've looked at open dot and close dot often, but now we're going to start to use a little more advanced notation. Okay, so I'm going to use a parentheses if it is not a part of the graph. So that 4 is not part because it was not equal to. And here I can use the bracket to indicate that 5 is a part. So that's where it's going to be equal to. Okay, so just keep in mind the difference between a parentheses and a bracket. And this will also come into play a lot later on when we're dealing with sets of numbers and solutions to things. Okay, so a bracket means it's part of. A parentheses means almost, but not quite. Okay, so now here's just our next little figure. We're talking about absolute value here. And remember that absolute value is how far away from 0 am I. I can be steps to the left or steps to the right, but that's how many units or how many steps away I am. Okay, so that's just what this is saying. And absolute value is denoted by those two lines, vertical lines. Okay. I'm always remembering how many steps away I am. So here's my absolute value, right? So the absolute value of 8 is 8 because I'm 8 steps away from 0. So let's look at this. So if I am looking at the absolute value of negative 15, I know that I am 15 steps away from 0. Even though I'm on the left this time, I'm still 15 steps away. So my answer there would be 15. Okay, so here's our next example. If P and Q are 2 points on a number line, we're going to call them kind of A and B. The distance, right, is the absolute value of the difference of those two. So I can subtract them and find the absolute value to find my distance. Okay, so now here's our example. This right here is example number 6 in your book if you're following along. So finding the distance on a number line. So P, Q, and R are points with coordinates -5, 7, and -3. So now I'm going to find the distance. Okay, so first thing I want to do is I want to plot those points, P, R, and Q, based on what I was told. So then A, I asked to find the distance between P and Q. So here I see P and Q, and I'm at -5 and 7, so I can go ahead and take those and subtract them, and then find the absolute value. It doesn't matter here which order I put them in, because 7 minus a -5 gives me 12, but -5 minus 7 is -12, and I'm taking the absolute value, so I can put these in either order. So now I'm finding the distance between Q and R, and that's going to be 10 units. So I can either plot them and count, or I can take the values and subtract them and find the absolute value. So now we're going to be evaluating some expressions. Okay, so when I'm evaluating expression, that literally means I take the value that I'm given, so here I'm given some x and a y, and I plug those into wherever I see those in the equation. Okay, so all I'm doing is substituting 3 for x and -1 for y in all of those expressions. Okay, so evaluating should come fairly easily and simply to you. So now we're going to look at a domain. So remember that the domain is all possible x values or all possible inputs. Okay, so often we see we're going to be dealing with rational functions here a lot this year. So the domain would be anything that does not make the denominator 0. So here, since I have this denominator, I can't make this 0, so I know that the domain is the set, right? Because we're dealing with set notation of all x values such that x does not equal 2. Because if x was 2, my denominator would be 0. So I can write that in set notation as well. Okay, so we're looking at the circumference of a circle. We're just talking about some domain events here, and this is example number 9. So my domain for R, and remember R is my input, would be all positive real numbers, because it does not make sense to have a negative radius on a circle. So we want to think about what we're actually dealing with, and not just the fact that these are variables or letters. So what we're caring about, right? And same thing with circumference. The circumference, which is going to be my range, is not going to be negative because we're dealing with a circle and values that go along with that circle. Okay. So now we're going to talk some exponents and some exponent laws. Okay. So again, remember this exponent just tells me how many times I'm multiplying this thing times itself. Okay. So if a equals 0, so if my exponent is 0, it doesn't matter what my base is, it's going to always be 1. And then if I have a negative exponent, I know I just have to move it to the other side of the fraction, right? So here we're in the numerator and I have a negative exponent. So to make that exponent positive, I move it to the denominator. Okay, so now we're going to evaluate some of these expressions with negative exponents because negatives are where we kind of get tripped up. So here I see I have 2 to the -3rd. Before I do anything, I have to get rid of that negative exponent. So I move it to the other side of the fraction. So now I have 1 over 2 to the 3rd, which gives me 1 over 8. And I do the same thing here, and I can do the same thing here. Okay, so I'm going to always just do this to get rid of my negative exponents to start with. So now here are some laws of my exponents, right? And we're going to be using these. So if I'm multiplying two bases that are the same, I can add the exponents together. If I have an exponent to an exponent, I multiply those exponents. I can distribute my exponent only if I'm multiplying inside those parentheses. And here again, if I'm dividing, I'm going to go ahead and subtract. And again, if I'm multiplying or dividing, I can distribute that exponent. Okay. So here are a couple of examples just using those laws of exponents. First thing we always want to do is get rid of the negative exponents, and then we can simplify from there. So here are the solutions. So the first thing I do is I kind of separate out what I'm looking at is my x's and y's, and I get rid of my negative exponents, and I see I'm dividing, so I can go ahead and subtract those exponents that I'm given. So now we're going to look at some square roots. So now remember, a square root is asking, what did I multiply by itself to get my number? So evaluating. So I know the square root of 64 is 8. Because I know 8 times 8, there's 2 of them, gives me 64. And I can continue on and look at these examples. So when I'm dealing with fractions, I know the square root of 1 is 1, and the square root of 16 is 4. So I can simplify that as well. Okay. So if I'm taking the square root of something squared, that's going to be the absolute value of that a. And so a can be any real number. So just remember, we're always going to end up with the positive values here. So here's that example, right? So if I'm taking 2.3 squared and then the square root of that, it's going to be the absolute value of that 2.3, which gives me 2.3. So now we can use a calculator, right? And here's there's many ways to do this. You can do this on Desmos, you can do this on your calculator on your computer as well. So here's just what it kind of looks like in a TI calculator. So I've got 2.3 to the 5th, and we always want to make sure that that's an exponent. And then I get my answer there. Okay, so now let's go back and just look at our learning targets, make sure that we understood what we were doing with. Working with sets, this may be the only real new thing that we've done in this section, so make sure that you understand the different notations. Then we graphed some inequalities and found distances on number lines. Evaluating was just where we plug in the numbers that were given. So we looked at the domain, which is all possible input values or x's. We looked at the laws of exponents and some square roots, and then we looked at briefly at what a calculator would look like. So now that we've gone through all of these learning targets and objectives, go ahead and work on that homework for this algebra review section.